you should have just finished writing down the steps in your toolbox on how to solve a one-step inequality. Right now what we are going to do is go through 3 examples. These 3 examples I would like you to write down in your chapter toolbox. Example 1, set up a column for solving, set up a column for graphing, set up a column to check your work. These are done just about exactly the same as an equation. The only thing we're changing is our inequality sign, so you're going to have more solutions for m rather than just one number. So m plus 5 is less than or equal to negative 11. We are trying to solve for m. The opposite of 5 is negative 5, so we're going to add negative 5 to both sides. Show your work by adding negative 5 to both sides or subtracting 5. Bring down what's left. n is less than or equal to negative 11 plus negative 5 equals negative 16. We then go over and graph our work. We always start with putting 0 in the middle. I put 6. We talked about what interval you can use. I'm going to just go with 8s. So 8, 16, this would be negative 8, this would be negative 16. We need a closed circle on negative 16. It is less than, so we are shading to the left. Now it's always important to check your work to make sure that you graphed it correctly, you shaded the right way. So when we check our work, we can pick any number in here that's going to be less than negative 16. You could use negative 17, negative 18, negative 19, negative 20. Doesn't matter what number you check as long as it's less than negative 16. I'm going to go ahead and pick the number negative 20 to throw back into my inequality. So negative 20 plus 5, is that less than or equal to negative 11? Different signs subtract. Negative 15, is that less than negative 11? If I look at where negative 15 is, it would be about here. I look at where negative 11 would be, closer to 0 on the number line. So it is true statement. I know that my answer is correct. M is less than negative 16. Number 2, maybe you should pause the video and try this one on your own. See if you can get it correct. Otherwise, if you're not comfortable doing that yet, go ahead and do the problem with me in your toolbox. Write down 15 is greater than a minus 7.2. I always start with KFC, and I need to add the opposite, which is positive 7.2. What I do to one side, I do to the next side. Bring down what is left. This cancels out. A less than, bring down my sign exactly the way it looks, and now I have to do 15 plus 7.2. When I do that, this is a problem where you're lining up the dot. Give it all you got. 15.0 plus 7.2. If you need to write that out, go ahead. If you're not comfortable with decimals and adding and subtracting them yet, you're allowed to use your calculator. You get 22.2. Alright, now I don't like the way this looks because like we talked about in your previous lessons, our variable's not listed first, and sometimes that mixes me up when I'm trying to graph the correct way. So this is one where I want to flip it. A is less than 22.2 for my answer. And you graph this. 0 in the middle. This one I might just count by 11. I need an open circle on about 22.2, so a little bit off there. And I'm shading to the left because it is less than. I really like when I shade in the 0 because that's such an easy number that I can check with to make sure I did my problem correctly. So when I check, I'm going to put in 0 and do is 15 greater than 0 minus 7.2. Well, 0 minus 7.2 is just negative 7.2. 15 is a greater number than negative 7.2. If that is a true statement, you know you did your problem correct. Example 3. I know how much you love fractions, so let's do a fraction problem. B minus 1/5 is greater than 3 1/10. KFC, we have a negative 1/5, so we're going to add 1/5 to cancel it out. What I do to one side, I have to do to the other side. Bring down what's left, bring your sign down exactly the way it is in the problem. And we have 3 1/10 plus 1/5. I don't have a common denominator, so I know I need to go back to my rational number rules, change this into improper, and find a common denominator. 3 times 10 is 30, plus 1 is 31/10. And then I want to have a common denominator here. 5 times 2, 1 times 2 is 2. I now have 31 plus 2 makes 33 tenths. When I go ahead and simplify 33 tenths, how many times can 10 go into 33? 3 times. And there's 3 left over, 3 and 3 tenths. E is greater than 3 and 3 tenths. To graph this, I always put 0 in the middle here. And then I'm going to just go ahead and count by 3s. And 3 and 1/10, 3 and 3/10 is going to be a little bit off of the 3, but pretty close to the 3. I need an open circle. I might just label it above there that it's 3 and 3/10. And open circle pointing to the right. Check it with a number that is greater than 3 and 3/10. I might just use a number such as, to make it work out, number 10. 10 minus 1/5, is that greater than 3 and 1/10? I do 10 over 1, change that into 5. 1 times 5, 10 times 5, greater than 3 and 1/10. 50 fifths minus 1/5 is 50 minus 1 is 49 over 5. Is that greater than 3 and 1/10? That is a true statement, so I know I shaded the correct way, and I have my problem correct. B is greater than 3 and 3/10. All right, go ahead and give your brain a break with the next slide on your Google site, and we will continue with word problems in just a minute.